Good morning, everyone. Let us now see about multivibrators. A multivibrator is a two-stage amplifier operating in two modes. The output of first stage is fed back to input of second stage, and the output of the second stage is fed back to the input of the first stage. If one stage is in saturation, the next stage will be in cutoff and vice versa. There are different types of multivibrators. The first one is bistable multivibrator. Why it is called bistable? It has two stable states and it needs external trigger pulse is required to change from one state to another. So here we have two stable states for a bistable multivibrator. Next is monostable multivibrator. Only it has one stable state and the other state is unstable or quasi-state. If external supply is applied, the circuit goes to the normal to quasi-state and after some time automatically returns to the normal state. As it has only one stable state, it is called monostable multivibrator. The next one is a stable multivibrator. Here, both the states are quasi or unstable. Without any external trigger, it changes the state automatically. Hence, this type of multivibrator is also called free running oscillator. Let us now consider a bistable multivibrator. Consider a simple fixed bias bistable multivibrator. Consider the circuit. So here we have two transistors Q1 and Q2. The transistor which draws more current will conduct and move on to the active region. It makes the other transistor to move to cutoff. Now we apply external trigger pulse simultaneously to both the transistors. For example, giving a supply VCC, suppose transistor Q2 is made to on position. It makes transistor Q1 switch off. Now we are going to apply external trigger circuits which makes the transistor Q1 on as Q2 is already on. So the external trigger does not apply on this transistor. When transistor Q1 is made to on position, it makes the transistor Q2 off. No two transistors are on or off at the same time. Let us now look on to the circuit operation. One of the two transistors will conduct harder and thereby reach saturation first. The 0 volt at the collector of Q2 is coupled to the base of Q1 which drives Q1 into cutoff. The VCC at collector of Q1 is coupled to base of Q2 holding Q2 in saturation. An input trigger pulse is applied to the base of both the transistors Q1 and Q2. Since Q2 is already in saturation, there is no effect on Q2. The trigger pulse turns on Q1 and drives the transistor into saturation. The 0 volt on the collector of Q1 is coupled to the base of Q2, driving Q2 into cutoff. The VCC on the collector of Q2 is coupled to the base of Q1, holding Q1 in saturation. This process will continue as long as there are trigger pulses applied to the circuit. The output frequency of the waveforms will be determined by the frequency of the input trigger pulses. Both the transistors are never on or off simultaneously. This is the the waveform of the bistable multivibrator. When Q1 is on, when Q1 is off, Q2 is on. When Q1 is off, Q2 is on. When Q1 is on, Q2 off. So no two transistors are on. So when I give a set pulse, so the waveform is being set, and when I give one reset pulse, so it is resetted. So this is the waveform of bistable multivibrator. Now let us see the triggering methods for bistable multivibrator. To achieve transition from one state to another state in bistable multivibrator, triggering is required. Such a triggering signal may be a step or pulse signal. There are different types of triggering methods: symmetrical triggering and unsymmetrical triggering. What is a symmetrical triggering? Only one input signal is used. In unsymmetrical triggering, two sets of signal can be used, one for set and the other for resetting purposes. So this is a simple circuit for unsymmetrical triggering. So we are going to give trigger on both the sides. So consider both the transistors are NPN transistors. So when we apply a positive step signal, the transistor moves to the on position. When we apply a negative step, transistor moves from on position to off position, because apply voltage need to be below the cutoff of the transistor. This is another unsymmetrical triggering using unilateral device, using a diode. So here a diode will decide whether to turn on this transistor. So we here give a negative pulse. So when this negative pulse is given, so here conduction will happen. So this will give from the supply voltage. The supply will go to Q2. Q2 will be making to active state. So this makes Q1 off. So when this diode D has been getting activated, then current flows to Q1. Q1 will be made to on, then Q2 will be off. So by using these triggers, we are able to control the on and off position of the transistor. So this is another type of triggering. Next one is the symmetrical triggering. In symmetrical triggering, we just give only one trigger. So when we give a trigger pulse, the diode conducts. If the diode D1 conducts, then it gives a supply voltage to Q2. Q2 is being made to on, then Q1 off. If diode D2 conducts, then Q1 is made to on and Q2 is off. First we are going to assume Q2 is in on position, Q1 is in off position. When collector resistance Q2 is large, D2 is reverse biased, no voltage drop across RC. Hence, points P and Q are in equal potential. When negative pulse is applied, the Q goes to negative, so D1 will be forward biased. The transmitting negative pulse at point B, which is collector of Q1, Then this negative pulse passes to the base of Q2, which turns Q2 off, and Q1 will go to on position. Hence, bistable transition occurs. So this is some of the triggering methods for bistable multivibrator. Thank you.